Hi, Professor. Mm, For this assignment, I have automated the deployment of a static HTML website across multiple EC2 instances using Ansible. Here, I have created mm, two Amazon Linux instance and two Ubuntu instance. Here, uh, Linux 1 and Ubuntu 1 are on public subnet 1, and Linux 2 and Ubuntu are in public subnet 2. Here, for each instance, I have kept the tags so that it will be easier to link and helpful in dynamic link. And for these instances, I have launched instances using a bug key, that is my private key pair. Now inside my Ansible static site directory, I have set up a complete infrastructure as a core solution that includes Ansible.cfg file. It defines a dynamic inventory file. It turn off host key checking and sets the default SSH and remote user. This eliminates the need to manually provide SSH and user info in each command. And the next one is AWS EC2 YML file. This is a dynamic AWS EC2 plugin configuration file. This enables Ansible to automatically detect newly launched instances that match the right tags. Here, as I mentioned earlier, we created a tag label as web server and another with tags as OS, and there are two group variables. One is for Linux, where in Linux it installs httpd and uses the default EC2 user, and Ubuntu installs Apache 2 and uses the Ubuntu user. Now in roles, this role contains all the tags needed to configure a web server. It contains main.yml file. This is my configuration. With main.yml, it installs the correct web server package depending on OS type. It starts and enables the service, as well as deploys a static HTML file using a index.html template. We have index.html template over here. It's a templated HTML file that displays the hostname and the deployment info. And next important one is site.yml file. This is the playbook that brings all together. It targets both Amazon Linux and Ubuntu server, uses a web server role, and it delivers privilege to install and manage services. Now let us check our configuration and connectivity, if it's successful or not. Now first checking the tree structure of our inventory graph. It shows that we have in total 4 instances and 2 are Amazon Linux and to our Ubuntu. Now let us ping if it's successful or not. Here all 4 hosts responded with a pong, ping pong, 1, 2, 3 and 4. So it means Ansible can successfully communicate with them over SSH and run modules. Now let us run another command. Localhost. Here all instances return a HTML response. This proves that web server is successfully running and serving the deployed content. Here as we can see our index.html file, we have this HTML file and it shows for each instance welcome to IP and deployed by my name, deployed by me, and this is for each instances 1, 2, 3 and 4. Now let us run another command. Site.yml file. Here it executes the site.yml playbook across all grouped EC2 instances. It applies the web server role which installs the correct package, starts and enables the service, deploys the HTML file. Now let us run another command that shows the family. Ansible OS family. Here it uses the setup model to gather OS family facts from each host. Here it shows two instances are from Debian family and two are from Red Hat, that is for Amazon Linux, and this Debian is for Ubuntu. This fact is used in the playbook to conditionally install the correct web server. Now to demonstrate the dynamic nature and scalability, I am launching a new instance. Let me name it web server Amazon Linux 3. I'm selecting Amazon machine image and selecting my key. Now editing the network setting is on default VPC. I'm keeping it in public subnet 1. Enable the public IP address, then selecting the security group. I have already set it as Ansible Web Security Group. Here it enables SSH and HTTP. Now let me launch this instance. Successfully launched. Now let us wait for some minutes until it gets initialized. It's initializing. Instance has been initialized. Now let me change the tags. Hit a new tag. Get the tag as a label and web server. Add a new tag. OS. I'm giving it as a Linux. Save it. Now let me go to my Cloud9 terminal. Now I need to run the site.yml file. Here a new instance is seen. I did not modify any playbooks or role. I simply reran the site.yml playbook because Ansible's dynamic inventory automatically detected the new instance. It identified the new host under OS Linux group, applied web server role to this new instance, installed Apache, deployed the HTML page and started the service. Here the newly added instance is this one. Let us verify it. 26. Yeah, this one. This proves the scalable nature of Ansible. Here existing nodes remain unchanged and only the new or changed nodes are configured. Let us also generate graph. Yeah, here it's added over here, and let's ping it. Yeah, ping is also successful. This one is successful. Now regarding the pros and cons comparison between Ansible and EC2 user data scripts for configuration management. Let us talk about the pros of Ansible. Ansible can be safely rerun without breaking systems. It detects infrastructure changes and adapts, as well as it is modular and reusable. It is stored in Git and easy to track changes. Similarly, can manage multiple instances from a control node. The demerit of Ansible is that it must have connectivity and credentials. Uh, it needs a orchestration or server with Ansible installed. Now the pros of EC2 user data. It is very easy to include scripts at launch, and everything happens during instance boot. Actually, it is perfect for basic installations. Regarding the demerits, it changes after launch, require recreation or manual fixes, and it has no state awareness, that is, can track or reapply missing configurations, as well as it is not scalable, hard to maintain across many instances. And then regarding the security risks, user data scripts are stored in plain text, and any sensitive data like hard-coded credentials can be exposed. Overall, in summary, Ansible is a better choice for long-term infrastructure management, security, and scalability.